Hello, welcome to Lab 5, Choose Your Own Adventure. I have chosen to analyze the motion of a bouncing ball and determine whether energy is conserved in this process using Newton's second law and the basic energy magnitudes. Through motion analysis and the computational model which I have created, I have found that energy was actually not conserved and it was lost to the surroundings. The fundamental principles involved in this lab are Newton's second law, which will help update the velocity and position of the ball, which will then be applied to the kinetic energy and gravitational potential energy equations, from which the change in energies were found and plotted against time in order to determine whether the energy principle was satisfied. I found a video on YouTube which shows the drop of an exercise ball. The length of the ball was calibrated to 0.65 meters, and the origin of the XY coordinate plane was set to the initial position of the ball drop. I then proceeded to track the object until it came to rest. From there, I exported the data into a CSV file that I would later use in the code for my computational model. This is the code of my computational model. Here, I input the initial conditions of the ball's mass, ball's initial velocity, time, and delta t. Proceeding, this is a piece of code that I use to extract the data from tracker, which I then use to find velocity. Here, I initialize the kinetic energy and potential energy of the ball. In the next while loop, I found net force using Newton's second law and updated the velocity and position of the ball. Here, I set an if function so that the model of the ball would bounce back instead of falling indefinitely. The value in the function was the lowest that the ball went, the distance from the ground to the initial position. Lastly, here the difference between final and initial energies were found, and then graphed according to the line of code here. After running the code, the computational model does show the motion of the ball accurately, and plots the energies of the ball. The green line is the sum of the change in energies, while the blue is the change in kinetic energy, and the red is the change in gravitational potential energy. As you can see, the green line initially starts out at 0, but proceeds to become more negative as time goes on. This shows that there is a decrease in kinetic energy while there is a small increase in potential energy. As a result of my computational model, I have found that the energy principle was not satisfied since there were external forces acting on the object because it was not a closed system. The energy principle states that energy is conserved and the sum of the total energies is constant only if there are no external forces acting on the object, or if the object is in a closed system. In this case, the object was found to not be in a closed system since there were external forces such as drag force and the friction coming from the ground. There is also energy lost due to the bouncing motion of the ball, and these were lost in forms of sound and heat. This is considered an inelastic collision. However, on the other hand, if we controlled the system so that it was a closed system, somehow where the bouncing motion of the ball is not affected by external forces such as frictional force, the energy principle would be satisfied and the sum of the changes in energy would equal 0, though that is not the case here. Thank you for viewing my lab.